Now that we're looking at the rational family of functions, we need to talk about solving rational equations. Now, how you know that an equation is rational is that you will have a variable somewhere and it will be in the denominator. You'll have a variable that's on the bottom part of a fraction. So all equations of this type, all rational equations, will have a variable in the denominator. So I look at this equation and it says 1 divided by x equals 3. Now, you know that 1 divided by something is simply its reciprocal. So when I look at this, I could read that the reciprocal of x equals 3. Now, if the reciprocal of x equals 3, let's think about it. Then x has got to be the reciprocal of 3. Because the reciprocal of x is 1 divided by x, and the reciprocal of 1/3 is 3. So to solve that equation, we just sort of looked at it, but the process we thought about was taking a reciprocal of both sides. Now let's look at something a little bit better. This equation says 2 divided by x equals 3x plus 4. By definition, it's rational because we have a variable that's in a denominator. So let's think, and you don't have to write this down because it's orange, about taking the reciprocal of both sides in this case. The reciprocal of 2 divided by x is x divided by 2, and the reciprocal of 3x plus 4 is 1 divided by 3x plus 4. Now, this didn't really help the situation because in kicking one variable out of a denominator, I've accidentally put the other x into the denominator. So let's look back at this black equation in the corner, and there's another sort of tool I can employ, and that is the fact that if I multiply both sides of an equation by one item, I don't change the relationship between the two sides. Now I'm going to pick my factor to multiply by very carefully. I'm going to multiply both sides of this equation by x. Now notice on the left side, the x's are going to cancel out, and on the right side, I'm going to end up distributing the x. So on the left side, I'm left with a 2, and on the right side, I have 3x plus 4 times this quantity x, which I can distribute to have 3x squared plus 4x. Now, this is advantageous because I know how to solve, or we know how to solve polynomials, and I don't have that x in the denominator of a fraction if, perchance, I think I'm allergic to fractions. So, when you can't just take the reciprocal of both sides and make things look better, you can always multiply by what's in the denominator, and often this will clean up an equation quite a bit for you. Alright, let's look at one more example. Let's solve 2x plus 4 divided by x equals 5. Now I look, and what's in my denominator here is an x, so I'm going to choose to multiply both sides by my variable x. Now on the left side, this causes the x's to cancel out, and I'm left with 2x plus 4, and on the right side, I now have 5x. Now this looks like a pretty normal one variable equation. I'm choosing to subtract 2x from both sides so that 4 equals 3x, and then I'm going to divide by 3 to get x by itself. Now I think I have my answer, but I'd better check just to be sure. So now I go back to the very original that I had written down at the beginning of this example. But instead of x, I put 4/3 into my equation. Now this is a bit of a mess, because now I have fractions within fractions. So I'm going to recall that when I'm dividing by a fraction, I'm multiplying by a reciprocal. And I'm not going to make any move to solve this equation. I'm just going to rewrite the left side so that instead of dividing by a fraction, I'm multiplying by a reciprocal. Notice that 4/3 and 3/4 are reciprocals. Now this second line here looks better than the first line I wrote down when I went to check my answer. Also, now, maybe I still don't like fractions. I'm going to go ahead and distribute 3/4 and see what happens before I multiply anything. So I multiply each item by 3/4, and look at all this cancellation that happens. Sure enough, when everything cancels, I'm left with 2 plus 3 equals 5. Now I know that wasn't the greatest problem to check because you had a fraction for an answer and then you had fractions within fractions. But if you'll calmly persevere and simplify, then it will work out, I promise. So, the big idea that I want you to come to class with is that you can manipulate an equation and probably eliminate some fractions if you'll multiply both sides by the denominator of your choosing.